So, very good evening to all of you. I am here again with you to come with another video on AC locomotive. In this video, I will discussing with you the basic block diagram of AC locomotive. What are the various equipments or devices that are inbuilt in AC locomotive, and this AC locomotive can be used for electrical traction purposes. This electric traction or AC locomotive is nowadays used in Indian railways, but it will be start around 1837 when the first AC locomotive come into the picture. As I have already explained to you that it is a part of electric traction system, and as you all know, in electric traction system we are use electrical motor in order to track the track purpose, in order to drive the vehicle. So the system is called as electric traction system. Now the question is how electric locomotive works. हमारे इलेक्ट्रिक लोकोमोटिव में किस तरीके से एनर्जी ट्रांसफर की जाती है और वो एनर्जी कहाँ से आती है, किस तरीके से हमारा जो लोकोमोटिव है वो आपका चलना शुरू होता है, कौन कौन से बेसिक कंपोनेंट्स, कौन कौन से बेसिक डिवाइसेस आपके एसी लोकोमोटिव के अंदर होते हैं, वी ऑल शेयर विद यू. This is, you can say that, the overall pictorial view or the main block diagram of this AC locomotive, which consists of number of equipment that I will discuss with you one by one, and also discuss the various components along with their working and why these equipments are used in AC locomotive for traction purpose. This pictorial view is only the just representation of your AC locomotive. Now, this is basically the internal structure of AC locomotive, and you all seen there are total 8 components present in an AC locomotive. With the help of this, an electric AC locomotive can rotate. On a diagram, I have represent the numbers 1 to 8, and these 1 to 8 numbers are constitute the various components of AC locomotive. For example, you have number 1, that is called as OHL, that is overhead transmission line. Your electrical vehicle that used in traction purpose can take AC power of a very high voltage. Generally, this voltage will be ranging from 16 kV to 25 kV, is taken from an overhead conductor, and this overhead conductor taken the supply from a near substation or a grid station or traction substation. So in this overhead transmission line, a very high voltage up to the rating of, as I have already explained to you, about 16 kV to 25 kV, they are working. Now in order to collect this high voltage, high power to the vehicle, we are using current collecting device, and in technical term in traction system it is called as pantograph. As seen in your diagram, number 2 represents the current carrying device or pantogram. A pantogram is an apparatus mounted on the roof of an electrical train to collect the power through contact with an overhead line. This is basically, you can say that, act as a media between a locomotive and the overhead transmission line. That means ये क्या करता है, ये आपके overhead transmission line से इलेक्ट्रिकल पावर को लेता है और इस इलेक्ट्रिकल पावर को लेने के बाद ये आपके व्हीकल को देता है. That is why this term is called as current collecting device, or technically it is known as pantograph. After this you have a third number. That third number is called as CB, that is called as circuit breaker. And in this traction system generally we are using air blast circuit breaker. Now as you all know, circuit breaker is basically a switchgear device that can be used for the protection purpose. As I have explained, circuit breaker, it is basically a switchgear protection device that can be used to protect the system against overcurrent, over voltage, and any type of fault if occur in this system. So whenever the system becomes healthy, the contacts of the circuit breaker gets off and the current or the voltage from overhead transmission line is given to the vehicle. But under faulty condition or under unhealthy condition, this circuit breaker is automatically operates and the contacts between two is open and the vehicle get excluded from the overhead transmission line. So you can say that this air blast circuit breaker is basically here used as a protecting device in order to protect your system against the high voltage, high current, and all that. Now, after that, this high voltage AC power is given to the tap changer transformer in number 4. And tap changer transformer, what he do, it step downs the voltage from certain high level to the certain low level depending upon the rated capacity of the motor that can used in your traction system. We are here using a tap changing transformer. So tap changing transformer basically depending upon over utility, it can step down a high voltage into a low voltage. As we know, a transformer is basically a device which work on AC. So in this tap changer transformer, your incoming will be AC, but at a high level. The output of the transformer is again a AC, but at a low level. After this low level AC, it is given to next 6th number device, that is a rectifier. And we all know this rectifier can rectify the circuit, that it can convert this AC into DC. Now the question is why we can convert this AC into DC. The reason being, here we are using a DC series motor for traction purpose. So in that case, your motors will require a DC supply, but we are getting AC supply from an overhead transmission line. And moreover, this overhead transmission line is working at a very, very high voltage, generally 16 kV to 25 kV. So first of all, we have to step down this voltage, and after that we have to convert this high voltage into DC. So for that thing, we are using this rectifier circuit. That is a point number 6. Although we know when the rectification process will be done, some ripple present to be there. So in order to remove all the ripple or all the unwanted signal present in that case, we are generally required a smoothing circuit or a filter circuit. So 7th number is basically a smoothing reactor, or you can say that a filter circuit, so that pure DC can be obtained after this rectification process. I think this is clear to all of you. Now, after this, the output of smoothing reactor is purely DC, moreover step down DC. Now this output will be given to the motors that are installed in the wheels, in the nearby wheels of this traction system. Basically not in a wheel, basically it is given to the motor, DC motor, and this DC motor is directly coupled with the wheels of the locomotive, and hence once this DC motor start rotating, it is coupled with the wheels of the locomotive, and hence locomotive will also start rotating in a direction. And in this manner your electric traction is possible. In this manner your locomotive can rotate in a particular direction. One of the most important thing that you should kept in mind, in case of this electric traction system, we are using a DC series motor. The purpose for using the DC series motor is certain thing. The DC series motor is having a high starting torque. Its speed can be easily controlled. It is small in weight, that is robust in weight. So due to these reasons, we can use this DC series motor as a traction purpose. Because in order to move the vehicle, in order to move the locomotive from one point to the another point, we are required a high starting torque. And DC series motor is one of the motor having a high starting torque. We have to control the speed of the locomotive. So in order to control the speed of the locomotive, we have to control the speed of the DC motor. So in case of a DC motor, the speed control is possible or easy. Or in other word, we can say that overall weight reducement, we are using a DC motor because DC motor are small in weight as compared to the another motor. I think this is clear to all of you regarding this thing. So as I have already explained, this is the pictorial view of your AC locomotive. So it will be understood to all of you. This is the modified version of your AC locomotive. Now, this is one of the most important things. As you know, we are using a tap changer transformer, and this tap changer transformer is having a very high capacity. It can convert this high voltage AC into low voltage AC. So there is certain losses occur in a transformer. Also, when the vehicle will start rotating, it will also create certain losses. Now, since these motors as well as these transformers are located inside the locomotive, so we have to remove the heat generated inside the vehicle to a very, very greater extent. Otherwise, what will be happen? Due to high heat, the efficiency will decrease, which will be not which will be not considered by us. So in order to remove the heat to a greater extent, we are using a cooling fans. This cooling fan is coupled with your compressors. So the amount of heat generated in the transformer, in the motor, automatically it will get it off. So your vehicle or the devices that installed in a vehicle get lower temperature, and when this lower temperature, it will be work on high efficiency. So this is all about this AC locomotive, how it will work, what are the various components that are used in AC locomotive. I think this is will be clear to all of you. So you must watch this video, and if you have any problem related to the any of the component or any of the device that are used in AC locomotive, you are free to ask me anytime. So thank you so much for watching this video. Thank you so much.